Okay, so we are starting with building a vWan global. This is a global object that inside this global object, we are going to create our apps. So as I told you, it's not going to be clear from the very beginning, but let's start with building this global object, the vWan global. So on Azure console, we are starting to build the virtual one and search for virtual one, and you will see this page, and here we are going to create the global object. And I will give it a name, global v1. So this is the resource group, and I'm going to build it in the West Central US. For the object itself, I will give the same name as the resource group. And there are two types of this global object, standard and basic. So standard, the difference between the two, that standard support more connection types. For example, if you want to connect your express route, it's only supported on the standard, it is not supported on the basic. But if you will look on Google it, and you'll see all the difference between the two. So let's create it. So this one is on the way. So what we're going to do next, after we have created the vWan global, this global object, we are going to create an hub. So we're going to create an hub, and we can create multiple apps on the same region. This one is we are going to create it on the US West Central. So you can create multiple apps. If you have the right use case, you can create multiple apps on the same region, and also you can create hubs on other regions, and you are creating those hubs inside the global object. Now, to each one of those apps, you are going to connect virtual networks. So virtual networks is just an example, but you can connect also site-to-site VPN to this app. You can connect point-to-site VPN, SD-WAN, express route, and so on. Instead of, this is a very similar to the TGW in AWS, a central location where you are making all the connection to this central location and controlling one place all the routing between the external networks. So what we're going to create next is this object, the hub. And I'm going to do that again from the virtual v1. If you will take a look on the configuration, you can see that here it's explained what is the difference between the basic and the standard. As I told you, the standard also support, for example, express route and also point to site, which is not supported on the basic. Now, let's create the hub. I will click New Hub. And I'm going to place it in West Central US. US hub. And I needed address space for this hub. So this is what I choose, 10.0.100.0/22. And you need to choose the hub capacity. So what is the bandwidth and how many intent routes you need in this environment. So I'm going to take the very basic one. And I will move forward. And here you can create your VPN gateway. All of those settings are available also later on. So if you choose not to activate VPN site-to-site, you can also do all of those settings later on. And we are now going to create the first tab. So after we are going to create the hub, the second thing, the third thing basically that we are going to do is create the NVA. So I will switch to this diagram, and those are the checkpoint. Those are the checkpoint gateway, and it's NVA, and it's a managed application. So basically, once we deploy it, you're not going to be able to manage them like you manage a virtual machine in Azure. You're only going to be exposed to the IP addresses of those gateway, and you will be able to manage them via the checkpoint management, create the SIG, register the gateways. But from Azure perspective, from the console, you are not going to be manage them. So it's basically, it's completely a managed solution by Microsoft, by Azure, and you're not going to be able to manage them. Also, the load balancer that is deployed as part of the solution, and this is not related just for a checkpoint NVA, it's coming with every firewall solution that you choose to deploy. If you're using a Azure firewall, it's also deploying a load balancer, and the load balancer is going to load the load balance between the NVA. The solution is not like the VMSS. Those are a static object that we deploy. Each one of the object has an interface, an external interface, ETH0, and internal interface, ETH1, that's leading to the internal network. So the management basically can be anywhere. It can be on-prem, on the cloud, it can be SmartOne Cloud. And in our case, we are going to manage the gateways via the external interface, via the public IP. So on the external interface, they have also a public IP. And we are going to manage them via the public IP. So let's see if we finish. We didn't finish yet. It's going to take, so everything take time here. And so let's talk about the traffic. How does the traffic works here? What we have on vWan is basically intent route. So we are controlling internet traffic, so we can enforce that peers that are connecting to the hub will go to the internet through the solution, through the NVA, and from the NVA to the internet. And we can control east-west traffic. So traffic that is traveling between the VNet to the branch, or branch to VNet, branch to internet. We can also control it through the intent route. So on the intent route, we have two routes. One route to the internet, you will see it later on. We can redirect it to the Cloudguard, and route between the spokes or between the private networks also through the NVA. And let's see if we complete it, and still not. From the management perspective, so this is my management. As you can see, I have just the management object over here. And after we will deploy our solution, the checkpoint NVA solution, we will need to register the two objects like any other gateways that you manage. Those are going to be placed registered in my management, and I'm going to push a policy. And I've already created a policy in advance, and of course I'm going to use tags in the policy. So I have here, as you can see, I have a data center object, the Azure. I created the app registration on Azure, and I connected it. This is the SPN, and I'm now connected. And this allow me to use tags from Azure. So I'm using dynamic objects. Wonderful. And we are going to talk later on about the policy, and if you're not familiar with the Cloudguard controller. So let's go back to the virtual .1. Now we are inside the hub. As you can see on the left, I have third-party providers, NVA, Network Virtual Appliance, and I'm going to create a network virtual appliance. I can choose here the provider. So Checkpoint basically is going to be the first provider that is going, they are going to announce it, and we're the first provider that done a full integration with this solution. And the thing is that now it's not GA, it's going to be GA by, it's supposed to be GA by the end of October. And it's not going to take me now to the marketplace. So if you want to take to test this solution and take part on the EA, just fill this form or send me an email, and I will help you to onboard. And for now, and this is also what you will get from us, that in the marketplace we are going to share with you private image. So since this solution for Microsoft is not GA yet, we will need to give you specific permission for your subscription. So you're going to see it on my marketplace private products. And this is the solution that we are going to deploy. So call it NVA for the resource group. We deploy it in West Central US. The application name is NVA Cloudguard. So this is the managed application, the one that is managed by Azure. And also it's created, also I place it in a dedicated resource group. The vWan hub is the one that we've created. The NVA name is Cloudguard. You can choose whatever you want. The scale unit. So here you need to choose what is the bandwidth that you will need. So we are going to release also a table that say exactly based on your traffic blend, what you will need to choose over here, if it's just a layer 4 or it's or you need a threat prevention and so on. I will start with the very small one, 2 instances. Also, we're creating a BGP and we configure behind the scenes. We are configuring a BGP on the gateways to learn all the traffic, all the routes from Azure. So this is, of course, a private ASN. If you want to change it, feel free to change it. And I'm going to generate a new key pair. If you have a key pair, you can use it. The Cloudguard version that is currently supported is the latest one, RAT110. And also bring your own license is the one that the license type that is supported. I will change the default shell to bash and I will create a SIG.
So I do want to clarify something about the license. This is going to be a consumption-based offering built from the Azure marketplace. Initially, we don't have that functionality yet, so feel free to play with it, but it won't be licensed in the same way that Cloudguard Network Security is licensed today.
Thank you, Eyal. Did you find the link to join?
Google helped.
Yes. Eyal, while we are deploying the NVA, can you elaborate regarding the GA? Where is the EA is available right now? When the GA is going to be released? What is the time frames?
Sure. So basically, this is the same image that is the GA image for the Cloudguard network gateways. So from our end, the only thing that is changing is actually deployment. The GA is sort of a rolling process while Microsoft deploys the ability to use dual routing intent. So this is available in 2 regions in the US, and it will be a gradual deployment throughout all of the 32 Azure regions. Once Microsoft finishes deploying routing intent to all of those regions, and by that I mean dual routing intent, then we will be GA. This is targeted for actually end of November. But if you wanted to test one of the scenarios, either east-west or internet-facing, that could be done tomorrow.
Okay. Great. So this one is going to take time. Like it's take like I think 10, 15 minutes, something like that. Let's talk about another things over here, activity that we'll need to do. So Azure is basically going to configure this solution. It's creating the load balancer, and it's creating the backend pool. And the backend pool are instances. And now, as I told you, our instances has two network interfaces. One to the external network and one to the internal network. And the thing is that on all of our solution, we configure health probe on the gateway themselves to listen on port and response on port TCP 8117. Now, the internal load balancer is going to send health probe to all the interface of the gateway. So it's sending it to the external interface and also to the internal interface. And this is creating a mess. So what we need to do, and this is just for the EA, so Microsoft and we are going to solve this problem. But for now, after the deployment, we will need to connect to each one of the gateways and to remove the listening, the responding of health check on the external interface. So after we will deploy it, we will need to disable it on both gateways. And you are going to probably to ask me regarding NAT. Does east-west traffic need a NAT? So the answer is no, because the load balancer is going to keep the connection and track the connection. So if this guy wants to talk with this guy, the default route is going to point on the internal load balancer. The internal load balancer is going to select one of the Cloudguard. Let's suppose it's selecting this one. And the Cloudguard is going to send the traffic directly to the destination. Now, the traffic back is going to the internal load balancer. The internal load balancer, remember this connection. This guy was sending traffic to this guy, and he knows to which Cloudguard he was sending the traffic, so he's going to send the traffic to the same Cloudguard, so the connection is not going to be dropped. So if he will send it to this guy, for example, the connection is going to be dropped, right? Because it's not in the Cloudguard table. So you don't need a NAT for east-west traffic. For now, we are not supporting inbound traffic, so ingress traffic is not supported because Microsoft does not allow to place here in the hub, does not allow to place application load balancer or network load balancer, an external one. So to overcome this issue, what you can do is create another spoke, call it an ingress spoke, and to place the VMSS solution of checkpoint in this spoke, and this spoke is going to expose all of your application to the world. And I have a diagram that I can share with you, and also I can show it later on. So this is how you expose your application to the internet. So we support east-west traffic. By the way, I have here a table that I want to show you, and I also going to share it later on the post. Is that of course the gateway is R8110. This is what's supported, and it needs to be managed also by R8110. And you can see all the supported traffic flow. So for our use case, what we are doing right now, we have just one hub. As you can see, everything is supported. So all the traffic flow are supported from site-to-site VPN to site-to-site VPN via the hub. We support this scenario, so we can route or Azure support this scenario. They can route the traffic through the NVA. Also, point-to-site VPN to site-to-site VPN, VNet to VNet, of course. So all of those scenarios are supported. There are some limitations by Azure that you can see that are written over here. Interhub in the same region is that if you have, you create a few hubs in the same region. So not all the scenarios are supported, as Azure has some limitation. And what is planned in the roadmap, and this is mainly by Azure, is to allow also cross regions. So if you have multiple apps in multiple regions and you want to inspect traffic between them, so this is not supported right now, and it's part of the roadmap. So the deployment is still on progress. So let's talk about the policy. So I started to talk about the data center object. As you can see, I created here a policy with a tag. So the tag key is department and the key value is pod. So all the assets with this key value, department equal to pod, will be able to speak with, to talk with the tags or assets that has this key. And how do you bring those keys? So after you create the data center object, you can add object from the controller. So you can see all the assets themselves, the load balancer, the virtual network, the asset themselves, and the recommended way, of course, is to use tags. Okay, and the idea behind tags is that IP addresses are changing for the assets. The internal IP addresses are changing. As part of the CI/CD process, you are tagging assets, and it's changing all the time, and you don't want to manage static object on the management. So all the objects, as they are updating on the cloud provider, they are populated automatically to the checkpoint management, and from there they are populated, also they are pushed to the gateway to dynamic objects. So if an object is being changed or IP is being changed on the cloud provider, it's automatically being enforced on the gateways. No need to change on the anything on the management, and you don't need to enforce policy, install policy, of course. So department pod, where those tags are coming from. So on the virtual machine, so this is one of the virtual machine, this is the QA. And in the QA, you can see that I have here on the virtual machine, I have tags, and this one has two tags, department QA, and it has also a tag name access with the value internet. And I have another assets in a different VPC that has just department pod. And I've created two rules from pod to QA to allow all traffic, and from a source tag access equal internet to the internet. And only this guy, the QA guy, has this tag, the internet. So basically only this instance will be able to access the internet, and we're going to test it later on. So the deployment is still running, and on the NAT, I can also use tags. So for example, here only the QA can go to the internet. So just for him, I need to do an address translation. So just instances with the QA tag will be able to be hid behind the gateway external interface. And what is this gateway external interface? I'm using here a dynamic object that is called local gateway external. And this is not coming out of the box on the checkpoint management. You need to create this object. And what is this object? Once we compile the policy on the gateway, each one of the gateway is going to put the external IP inside this object. So on the solution, you might have many instances, right? And the packet can go to this object, and we don't want to create multiple rules. So we create one rule, and we're just using the dynamic object. So if the packet will go to this object, this gateway is going to hide the packet behind the external interface of the gateway. Once the packet will want to go, the destination is going to be the internet. And if it's going to hit on this one, it's going to hide it behind his own IP address. So this is why we are using local gateway external. Instead of creating the object themselves, the IP addresses, and put multiple rules, we are creating just one rule. Just bear in mind that once you put an object over here, you're going to see it first with the letter S, and S is for static NAT, and we are not doing here static NAT. We want to do hide NAT. So if you are going to deploy the policy, install the policy like that, it's going to fail. So just remember, right click on the object, and the NAT method should be changed to hide. So you should see the letter H over here. And for the same, we don't need this rule, but I just want to show you how to use the local gateway internal. So internal is the same thing. You just, it's going to put, the gateway object is going to put the internal IP inside this object. How do you create those objects? You just need to go to new, more, network object, and we have here dynamic object, and you need to put here the local gateway internal, exactly as I wrote it, and local gateway external. You need to create two objects. So here on the policy, I have an any accept rule at the end. I just left it like that because I will need the access over SSH from my computer in order to disable the health probe on the external interface. So we are going to first install this policy, and then I'm going to change it to drop. Wonderful. So we have the checkpoint solution. Let's take a look on the NVA. So I'm in the vWan hub, and in the vWan hub, I will go to the hub, and the NVA is deployed inside the hub. So in the hub and network virtual appliance, and I have the Cloudguard. And as you can see, you cannot manage it. You cannot see anything. You just can get the IP addresses. So what I'm going to do next is open Smart Console, and I will start adding the object. Let's do that. So I will take the public, we take the instance name, and let's create the first object. So gateway, you can use a wizard or classic mode, or whatever you want. So this is the name, and the platform is going to be IaaS, Cloudguard IaaS, and the IP is 13.78.206.201. Create the SIC. So by default on the image, we have a default route to all the internal IPs, but the BGP is going to overlap, or basically is going to create after it will be configured, is going to create the routes. And let's do some editing. On the network interface, we will need to remove the spoofing. So on the network, we need to remove the spoofing. And I want to configure the identity awareness blade. So without enabling the identity awareness blade, all of the policy that we set with the tags are not going to work. So identity awareness is a must. And we also need to configure it. We don't need the wizard. And I will also activate application control. On the identity awareness, I will activate the identity web API. I will allow access from all the interfaces, and I will need to add here on the authorized client a local host. So if you don't have a local host, just create a local host. It's a host object, local host with the IP address 127.0.0.1. So basically this is it. This object is ready. And now I'm going to create the second one. This is the second one, and the IP is 13.71.214.142. 71.214.142. Need to choose the platform. Identity awareness, application control. On the identity awareness, again, set the identity web API. On the network, remove the spoofing. And let's publish and install a policy. So publish is done. So we will let it run, and now let's configure the connections between the VNets. Okay, we have two VNets. One is in UK, another one is in US Central. So by the way, this is also supported. I don't know if it's going to be a common use case because it's going to cost a lot of money, but we have the central hub that is deployed on US West Central, and we can connect not just VPC VNets from US Central, but also VNets that are located on different regions. Okay, so let's take a look on the VNets. So those are the virtual network, and we're talking about this one, which is located on the West Central US, and this one, which is located in the UK South. So how do you connect these virtual networks? It's easy. You don't do it within the hub, although it makes sense that they will do it from the hub itself, but you're doing externally. So from the global vWan, you have here on the menu virtual network connection. So right now I don't have any connection. I will click here, add connection, and let's connect UK first. And hub is US hub. The resource group is I think it's this one, UK US QA. No, it's the other one, UK. Spoke O2 UK. I will need to do this setting, propagate to none, and associate with the default route table. So the default route table is, for now, it's empty, and intent route is going, once we will configure it, is going to inject the routing to the default route, and this is going to propagate inside the VNets that are connected to this hub. And we're going to see it later on. So let's create it. The thing is that we cannot create another connection before this connection will be made. So we have to wait. And in the meanwhile, what we can do, I can connect the two gateways. So let me connect to the two gateways. Let's take the IPs from the vWan. So I have the IP address. So let's open a connection. So this is Cloudguard 1. Let's take the address, and I need to change also the key. This is the second one. I change the keys. So we are starting with the first one. So ET80 is the external one, and we need to disable the health probe on this one. So this is the IP address, and I will share with you also the command. But if we will not fix it till it will be released on the GA, you will need to do to run this command. So this is the command that you will need to run. And I will need to run the same command with the external IP of the second gateway, 229. So we are good. And let's see if we have the connection. So we have the first connection, and now we can create the second one. And the last, basically the last thing that we need to do is just the intent route, and that's it. And we are done, and we can start to test traffic. So let's add the second connection, and this one is US resource group, US prod, US, and we connect it to the default, and let's create it. In the meanwhile, I want you to take a look on the routes. So let's take one of the virtual machines, and I want to check the effective routes before I change the route and after I will change the route. So let's take this one, US Web. And you can check the effective routes if you are going to the virtual machine and networking. You select the interface, the network interface, and on the menu at the bottom, you're going to see effective routes. So now you're going to see many effective routes. Most of them are non-relevant or not enforced. You can see this one was created once we have done the peering right now. So this is the VNet peering. You see that the default route is the default going to the internet. This is something that the Azure configure, and all of the rest are not configured. Okay, and it's going to be the same also to the other virtual machine that is connected to different to the one in UK. It's going to have basically the same routes. Those are the default beside this one that we have created, the VNet peering. So it's still creating it. Everything take a lot of time here. Great, so we have another connection. Okay, the two virtual networks are connected, and we're good to go. So where do we configure the intent route? So on the global vWan inside the hub itself, we have the routing intent. So we click on the routing intent. By the way, let's take a look on the effective route. So I connected the two network, the two VNets I've connected to the default route table, which is now empty. But let's check it before I configure the intent route. So the route table, I take the default. So it's empty right now. And the intent route is going to configure it and inject the route to the VPCs, to enforce the route on the VPCs, on the VNets. So this is the route intent, and here you can control internet traffic. We are going to send it to a virtual appliance, and we're going to send it to the virtual appliance that we have deployed. You can have many NVAs. And private traffic, we're also going to send it to the virtual appliance. And we can save it. And basically, this is it. After that, we can start test all the traffic flows. So what we are going to check, we are going to connect. So we are going to check based on the policy. We are going to check connection from department prod to QA. So the US machine is going, where I'm going to do curl or ping to the instance on UK, which has the QA key. And let's see if it's work. And then I'm going to try to ping from the QA machine that is sitting in UK to the internet. So we want to see that the identity awareness is working, and also to check that the access is working and all the route is fine. I'm not sure that it's going to work, since Azure, it's we are struggling with issues all the time with routing and all kind of stuff. But this is why it's still an EA. But let's see. So let's refresh the page over here on the effective route on the instance. Let's see if the route has been changed. And the route has been changed. As you can see, the internal networks are routed to the virtual network gateway. And what is this IP? This is not the IP of the one of the gateways. This is the IP of the load balancer, the internal load balancer. Okay, this guy. So route to the internet, route between the network to internal networks. Everything will go from the VNet to the load balancer, and the load balancer is going to send it to the gateways. So the effective route, the route has been enforced, and we can test it. So I'm going to the virtual machine. This is a US virtual machine. Let's select it again, and let's connect with serial console. So this is my IP, 192.168, and I'm going to run curl to 172.16.14. Let's see if it's working. And it's working. Let's see if we are seeing this log on the firewall. So let's see, we are looking for destination 14. And we see this that it has been enforced. It's reached the firewall, and we see the IP of the source, and we also see the object. This is the name of the object on Azure, right? And this is based on the identity awareness, the tags names. And now what I'm going to do next, let's see if I will take here as as a source 192.168.1.4, and I select the connection, okay, to 72. Let's try to ping. So I don't have a NAT rule, but it's going to be blocked. So it's going to be blocked because it's going to work, but it's not going to work because, so I'm going to see the access rule, but I don't have ping because I don't have a NAT rule. Okay, and it's a work because it's working on rule number 3. Okay, so this is why it work on rule number 3, but I don't have a NAT rule. This is why I don't get a respond. Now let's connect to the other virtual machine, which is in England, and I will try to open to do a ping to Google, and it should be work because it's going to go through rule number 1, number 2, okay, and I have also a NAT rule for the QA. Okay, so let's see if it's working, and let's do here the source. The source should be 172.16.1.4. So I'm connected to it. Let's ping and see if it's working, and it's working. Connected to the QA. Yeah, so it's working, and I have also the log, and as you can see, it's going through rule number 2. So everything is working. Everything is working through the firewall, and this is how you do it. So in in 1 hour we configure the solution start to end. Not too complicated. I'm going to send you an email with a link to the post where I'm going to place this recording. So Netanel and Eyal, let's answer some questions. Did you add some questions that might you want to repeat them, read them out loud? Eyal?
So we answer all the questions. There was few good questions regarding the availability zone inside the NVA. So if the question was regarding the NVA instances to be deployed in different zones, right now there is no option to configure it. It's a good point. We will take it with Microsoft and check if it could be possible to configure. So this was a good point. Regarding the SSH connection. So at the moment, we must have SSH connection because we still need to do some manual configuration. But according to Microsoft, once we will go to GA, they won't give us the SSH connection. But you won't need it because everything, most of the things that we need to configure could be done automatically by us. So someone mentioned the vWan cloud. To configure the vWan cloud and get the token and everything from the gateways, you need SSH connection. So it might be also done by the CME. So we are working to make everything more automatically. So we will include the CME in all this process. And that's it.
I'm sharing my email on the chat if you want to take part of this EA to be familiar with this solution before it's released to GA. Just drop me an email and I will make sure that you will see the solution on your private products on the marketplace. And if you have, guys, any questions, do we have any other questions? This is the time. And if not, we will end the session. I don't see any questions that are coming. So guys, Netanel, Dimitri, Eyal, thank you very much. Thank you very much, everyone, for being with us today.
I do want to share some fresh news from Microsoft. We are going to remove the requirement to whitelist the managed application. So this should be available without the need to contact us. Microsoft will still need to whitelist the routing intent feature, but as we move forward towards GA, this should be lifted in the next few weeks as well.
Wonderful, good news. But by the way, so if Microsoft need to white label the intent route, what is the process? The customers still need to approach us, and we need to speak with Microsoft, right?
It's basically there's a mailing list that you send an email to. You give them the subscription ID, and in a few hours they whitelist the account for routing intent.
I see. Okay, wonderful, good news. So thank you, everyone. Have a nice and peaceful weekend, and bye-bye.
Thank you, Shai. Bye-bye.
Bye-bye.